steel structures. Okay, so how these steel structures will be work out in our construction and industrial field while designing and modeling as per the BIM also we will discuss on that, because actually the steel structures, the detailing work what we are going to do will be have some more information compared to RCC structures, because RCC structures is also will be there, but meanwhile some of the construction we have to do steel structures, because the steel structures what will happen, it will be recycle the material, because it will be never lost. If you are constructing any building with steel structures with all MS or carbon steels with the help of welding, so we can again recycle, we can again dismantle them, and we can get it some utilization for other project also. Yeah, someone will sell that all with the scrap, so that is recycling process is possible for the steel structures. Okay, so that the reasons most of the buildings we will design with the steel structure, and meanwhile the steel structures will be give less weight compared to RCC, because the RCC, the concrete, cement, rebar, it will be give huge weight in the building, and it will be having a more loads also. Compared to steel, it will light gauge steels will be there, hot roll steels will be there, so they will give less weight, and they are affecting on the building with the loads, it is very less. So that the reason most of the company people right now they are using all steel structures only. So nowadays steel structures has huge technology has improved, and for the fabrication part also it is good right now, and compared to RCC, most of the company people, most of the expenditures we are going to do in the steel structures only. It is also getting less cost, the budget also it's getting very less compared to RCC, because RCC it will be permanent and it will be give some life more than 40-50 years maybe, this load basis. But steel structures it is giving the more compared to RCC, because it will be never lost. If it is having the building strength is getting less, so again we can recycle, we can dismantle, and again we can able to construct that one. So material loss is also very less compared to steel structure, RCC structures. Okay, so here the steel structures what we are going to work, it is also going to be do the designing, and it is also going to be work out for the modeling and information parameters, everything we have to be work out. So here the steel structures we will work out on the civil. So this also it comes under civil engineer people, because the civil engineering peoples will be work out for the steel structure, so we will call the steel structures. Okay, so in the market these steel structures again we will have two types of structures. One is PEB structures and another is universal structures. Okay, so PEB structures, universal structures, there are two types of structures we are going to be design and we are going to be work out in the projects. So what is PEB? PEB structures is nothing but pre-engineering building. Pre-engineering building. It is going to be fabricate each and every component with the help of welding. That structure we will call as a PEB structure, pre-engineering building. And here the universal structures, it's a fabricated structure that we will call as a I-section structure, I-section. Because whatever the steels it is there, it is already has been fabricated. It is no need to fabricate again. It's a ready-made, it will be getting, and that we will call as a I-section structures. Okay, so PEB structures is different, I-section structures is different. So most of the company people's these PEB structures they are going to be work out in the Tekla. You know the Tekla tool? There is one software Tekla tool is there. With the help of Tekla, they are working in PEB structures, not universal structures, because the PEB structures is going to be work out in Tekla tool only. So nowadays most of the companies still they are working with the Tekla. because here in Tekla it is going to give you the detailing drawing or model. It will going to be get it in the Tekla, because each and every components with nut and bolts also it is going to be get in Tekla easily. The same way we can do it in Revit also the same. But the information purpose Revit is going to be utilized nowadays, but for detailing purpose the Tekla is going to be utilized. Okay, so some company when they are going to design the steel structures, they are going to be work out in, if they require information purpose the model, so they will go for Revit. If they require the information as with detailing, so they will go with Tekla. This tool they are going to be preferred, because in Tekla also we will able to create the model 3D. Along with the 3D, each and every component we can get the information with detail inside the properties and parameters we will get it. So nowadays most of the companies preferable, so some of the companies they are only preferring steel structures for the design, because here in Tekla we can design the steel structures, light gauge steel structures also we will design, light gauge steel also we will design, and hot roll steel also we will design. Okay, so there's all companies peoples they are working in the steel. Nowadays Autodesk company has improved, and they have also given us all information how to design the steel structure. So separately they have established on menu steel separately. That is not a PEB structure, that is all universal structures. So that is related to universal structures only. But some of the components we can able to get model through that PEB also, we can do it in Revit also. And there is one more tool is also there, that is also this PEB structures is going to be work, that is IFC tool. This IFC tool is from Autodesk company. IFC also one of the 3D model tool. You can check it in Google also if you have any doubts on that. You can see in Revit also we can able to export our model in IFC. IFC also it is one of the tool. This IFC also we will utilize for steel structures modeling. But in IFC only the light gauge steels only we can able to design, light gauge. Only light gauge steel is able to design in IFC. But here in Tekla we can design light gauge as well as hot roll steel also. But come to the Revit, we can design both. Here light gauge also we can able to design, and we can design hot roll also. Light gauge steel also we can design in Revit, and hot roll steel also we can redesign in Revit. So both we can do it, but here in Revit we will utilize for information purpose, that's all. Modeling with information. Detailing will be get very less, but information we will get more. Compared to Tekla, compared to IFC, Revit is giving the more information along with the model. So here in the Revit we are going to work out easily these universal structures. These universal structures we are going to work out here with the help of I section, because this I sections already it was inbuilt with family, it was there wherever we required we can able to work out. So that is the reason here these steel structures in Revit we will use with the help of I sections only. So here in I sections you will get universal columns, you will get universal beam, that's all. So with the help of universal column, universal beam, we are going to work out for steel structures, because universal is nothing but here this is I section, it will become like that. It it will be look like that. This is totally I section, steel structure will be there. From here to here, this is the thickness T, and here this is, we will call as the web, and from here to here this is the height, and from here to here this is the width, and here to here where it will become, that is the length. Like that, these I sections we are going to be work out in universal steel structures. But come to the PEB structures, here we are going to use all MS plates only. MS plate in PEB structures. Because whatever the I section you can see in universal steel structures, that the same I section we can able to prepare in PEB structures also with the help of MS plate. And here whatever the MS plate they are going to use, minimum thickness is 12 mm, maximum 10 mm, maximum 12 mm thickness. The MS plates we are going to utilize here for the pre-engineering building structures, that we will call the PEB structures. So here how it is going to be happen means, the I section if they want to create in PEB structures, so here one plate they will keep with some thickness, again one more plate also they will keep as a vertical thickness, and again one more plate is going to be kept in bottom with same thickness. So like that, here the I section they are going to be designed in PEB, like that it is going to be designed in PEB structures. So here what will happen, this plate is going to be welded here. This is going to be welded, and here also it is going to be welded. With the help of welding, it is going to be joined, that the structures. Because one plate, here one more plate, again bottom one more plate. So that is going to be joined. But here in universal steel structures, the ready-made from the factory itself only, that I sections, a membrane will be comes directly. So this component we will call as a membrane also, membrane, steel structures membrane. I section column, I section beams, this all calls as a membrane. Okay, so like that, this PEB structures, the peoples they will utilize it. So the PEB structure separately, some factory will be there. There is some machineries, because this steel structures is related to some of the components. The technical is for mechanical also, because here the welding, nut and bolt, washers, studs, nails, anchor fasteners, the many things is related to the this mechanical technical sides they are going to be utilized. So the person who is working in the steel structures, they should know the knowledge of all, some mechanical technically knowledge should be there, because without mechanical technically knowledge, if the person is going to be work out in the steels, he may not get the design perfect. So here the welding, which type of welding you are going to utilize. This is arc welding, V weld, butt weld. There is a number of welding categories will be there. So that type of welding we are going to utilize. And here we have to be put some nut and bolt, washers. Then we have to make it holes of all the steel structures and MS plates. We have to make it joints. We have to make it a joist cuttings. So there is a different concepts will be there here for steel structures, for jointing each and every component in a model. Okay, so nowadays this steel structure where it will be utilized. You can see there will be a big this what we will call overhead bridge. You can see there will be roads. They are making as steel structures, not RCC. Nowadays, steel bridges. You can see the river bridges, canals bridges. This all consist with steel structures only. Because the bottom they are placing as a RCC only. It is supporting, but the above part it's going to make with the steel structures only. Nowadays, you can see big buildings also, they are constructing with the steel structures, because it is stressless, it's not going to be give more compared to the RCC. So mostly this steel structure where it is going to be utilized, where the mud, the soil is very loose, and that area the persons is going to be utilize the steel structures design. Because what will happen if the mud is very loose, maybe when the rains come continuously, the mud is going to be get loose, maybe your building is going to be fall. But steel structures is connecting with the help of welding, nut and bolt, plates, anchor fasteners, everything will be there. It will be never fall, the steel structure. It will be get some stiffness, momentum will be happen, but it will never fall. So actually some countries continuously their area will be get some earthquake, okay, bhukamp. So like Japan, Kuwait, these countries yearly some 3 to 4 times they will get earthquake, because their soil will be having loose, and due to that heat reduction the earthquake is going to come continuously. So that's the reason those country peoples always they will use for constructing the building with the steel structures only. Because what will happen when the earthquake come, the building will be get shake, it will be get vibrate, but the building is going to be stable. But if it is in having RCC, it will be fall down. So there will be a risky in RCC. So that's the reason the persons who are going to be construct with a huge high-rise building, they are preferring steel structures. So Kuwait, all buildings you can find they have been designed with the steel structures only. Some buildings you may be find RCC, but big high-rise buildings they are all constructing with the steel structures. If you go in Japan country also, they are also constructing a big high-rise building with all steel structures, not RCC. Because instead of RCC column, they are placing I-section column. Instead of RCC beam, they are placing I-section beam. And foundation is also with the help of plates, nut and bolt, and along with rebarring and concreting also they are doing, because it is giving some straightness. But the vertical supports it is using RCC, it is using universal columns, I-section columns. They are not utilizing any RCC columns. So like that the steel section, even the floor also they are utilizing plates, MS plate. So the roof also they are utilizing MS sheet, metal deck sheets they are utilizing. So nowadays most of the company right now in India also they are utilizing the floor, the columns, the beams, these all consist with the steel structures only. If you go any industries also you can find there is a steel structure. If you go any metro station, any metro bridges, you can see the railway bridges, railway stations also. If you go, you can find all they have constructed with the steel structures only. There is a big sheds, parking sheds, and you can find there is a big this what we will call it as this manufacturing sheds. This all comes under steel structures only, because the roof they are keeping as a metal deck sheets, and the metal deck sheets is supporting with the purlin beams. That purlin beams also steel structures, and the purlin beams is going to supporting the beams, and from the beams it is supporting the columns. And the columns, the base, it is consisting with some pedestal footing, and with that it is going to be constructing a big factories, sheds, parking sheds, even the metro stations. This all it's going to be constructed. And the floor also they are keeping with MS plate consist with, and along over this they are going to place the some tiles materials or some marbles materials like that they are placing. It is holding, and it is giving more stressness and stiffness also. So that here also we are going to be work out. So here in PV structures we are going to be work out here all with MS plate only. So here you will get here in PV structures also we will make it a structural column. Structural column also we will make it here, because with the help of MS plate. Then a structural beam also we will make it with the help of MS plate. And here we are going to utilize the trusses. We are going to utilize the trusses And here we are also going to utilize the beam system. Beam system is nothing but a floor. The purlin beam, how it is going to become, that is beam systems we will call it here. Okay, and we will utilize here the bracing. The cross sections of the beam we will call as a bracing, structural bracing. So in universal also we will going to utilize the same. So for steel structure purpose only, this PEB structure and I section structure, both we are going to utilize here for making the steel structure design. So it's a very interesting subject because some people will be choose the steel structures for making the building design, because very less cost and no more work. Just you purchase the I section column, you just fix it with the MS plate along with the nut and bolt along with the weldeds, and it is going to be stable. So the construction time taking period is also very less compared to RCC, because in RCC we have to purchase concrete, cement, sand, we have to mix it, we have to make it grind, and again we have to pour it, and again some workers needs to make it the centering work like the reinforcement, everything. It will be take a lot of times. But compared to steel structures, it's a very less time. Within short period we can lift the building, we can make it execute the building with the high rise, some 10-20 floors, so within very short period. So like that here they are utilizing. So here one more it is there, metal duct floor we are going to utilize, metal duct floor, because the sheet will become like that, metal duct. These are the metal duct sheets right now all the company peoples are utilizing, because these sheets, it's going to give the flooring, it is going to give the stiffness of the floor for placing the RCC, concreting some thickness 100 mm, and again the finished floor is going to be get it over this RCC floor. So how it is going to be constructed right now in the building, because here we are placing I section, here also we are placing I section. Between I section we are placing a beam here. So in single line I am making, and below here we are keeping a pedestal. Here also below we are keeping a pedestal, and above how it is going to be constructed, we are placing a this metal duct sheets like that over this beam, side to side they are placing, and after that over this metal duct sheets they are placing some 100 mm RCC floor. 100 mm RCC floor it is going to become, and after RCC floor above there are placing again some 75 mm the FFL tiles. So this is SSL and this is metal duct. Metal duct it is going to be placed, and above that the person is going to be moved. Like that all the buildings is going to be designed the floor in such a way, because beam to beam surrounding they are keeping metal duct sheets, and over this metal duct sheets they are giving a RCC cement, RCC concreting floor, some 100 mm only, not more than that. Exactly 4-inch thickness the slab they are making over this MS floor, because the metal duct is supporting with the beam, steel structure beam, I section beam, it is supporting 4 sides, and in middle also it is going to give you the supports, and over that the RCC floor is going to be make it as 100 mm, and after over these RCC floors again some 75 mm they are placing the tiles. So they are not making full area with reinforcement. Its reinforcement is not at all used in these steel structures. They will never use. Only the steel structures, the reinforcement is going to use in the pedestal foundations purpose only the reinforcement is going to be utilized. But the rest of the area there is no rebar modeling, nothing will have been used. Even the floor also no rebar, only the concrete with cement and sand in mixing, grinding, and it is placing over these metal sheets, metal duct sheets, and after that metal duct sheets again with cement and with that help of tiles they are placing the floor. So easily it is coming, and it is giving huge life also, because the metal deck sheet is MS sheet. It is holding that material, and it is holding with the tiles also, this RCC. So everything is coming with the supports. So if you pour number of weights also on that, nothing will be happen, because MS steel, iron, it is holding more weight. It is not getting any bends, nothing, because the stiffness is more here, this MS sheets. So nowadays most of the buildings has been constructed like that only. If another floor, same process. If you get another floor, same process. Columns, beams, metal deck sheets, over that there is a floor. Again column, beams, metal deck sheet, there is a floor. Like that, number of floors they are going to be constructing. And after constructing these steel structures, the interior part they are using wall also, brick wall they are using, and some of the offices or some of the commercial building they are utilizing partition wall, gypsum board wall. The doors, glass door, glass wall, curtain wall, everything they are using. But nowadays, most of the software buildings company, they are utilizing the steel structures, because the structures they are developing, and the surrounding the structures they are keeping all curtain glazing wall, and they are making everything looks like a RCC building. But inside if you go, you will find the steel structures will be there. And inside interior, they are utilizing some area, they are utilizing single brick wall, and some area they are utilizing partition wall, wooden wall, like that they are utilizing, because very lightweight partitions walls they are utilizing. In the market there is a hollow lightweight brick also will be available. So they are taking that hollow brick, cement blocks brick, and they are making the wall. So rooms it is going to creating, and it is giving the rooms partitions everywhere where they are required. And the building is stiffness, more durability, it will be there. So like that, this steel structures is going to be worked out, and it is utilizing in the market with the same with the help of this I section column PEB structure we are working. So in the market, Tekla, the tool is going to use for steel structures. IFC also going to be using, some of the company peoples, and nowadays Revit is also going to be utilized for the steel structures we are working with all information. Because here nut and bolt also with the how much the diameter, what is the pitch of the thread, how much the size of the washer, even the anchors, studs, even the holes, everything it is going to give you the information here. And if you are going to do the welding, so what thickness of the welding, what type of welding, and what is the durability, everything it is going to be worked out here in steel structures. So all the company peoples right now in the market, they are working the same steel structure. So nowadays most of the people are preferring this steel structures only. Okay, so this is the theoretical part, you just remember, because in steel structures, structural column will become structural beam. This structural column and beams will be nothing but I section beam, I section column, that we will call as a universal beam, universal column. Okay, and there will be a trusses we are going to place. You can see the trusses in the some of the bridges. You can see the side support they are placing the trusses. If you see some of the buildings like if you go in the railway stations, or if you go in industry, you will find the building is holding totally the four sides with the trusses only. It is holding the purlin beam, purlin. We are utilizing the purlin beam, the horizontal or vertical types of supports which is going to keep in the top, that beam we will call as a purlin beam, purlin. Remember this word, because steel structures peoples, we are using this purlin beam for holding the slab or roof, what we will call it. So that is also it is utilizing here. And beam systems, wherever the floors, wherever the trusses supporting where they required, we are utilizing beam system. And here we are utilizing bracing. Bracing is giving the angular supports between beam to beam, between one beam center to the another beam center, and it is going to be connected with the columns also. So if you find some of the bridges, if you go some railway bridges or some river bridges or some canals, and you can see if you go some of the roads also right now with overhead bridges, they are working this all bracing systems there for the supporting purpose of the columns. It is giving some stiffness to the column. For supporting purpose we are utilizing here the bracing. Bracing is nothing but that is also I section column, but it is placing in the angular way with some supporting strength and it is going to be utilizing in the columns to beam supports. So that also we are utilizing here. So with this way, these are the components is going to be work out for steel structure and it is going to be utilizing in the projects. Okay, so it's a simple and a very less concept of subjects of steel structure. So you have to be go and you have to be work out here while working in a project. Okay.